that went okay with you. I'll check those out. I'll grade them and update the grades. Let me begin this next section, Chapter 5, Section 5. It's called Adding and Subtracting these things called polynomials. And we'll just discuss real quick what this is about, okay? Up to this point, we started with these properties of exponents, right? All of that has been so that we can be comfortable doing what we're about to do the next few sections, all right? Being able, what do you do when you have a power to a power? Or, do you add them? Do you multiply the powers? All of that's just leading into this. So adding and subtracting, right? Adding and subtracting, those are two operations that we've done our whole life, right? Then we have this thing called polynomial. Well, poly means what? What's that? Many. Many. So we have many, what? Nomials. What's a nomial? Well, that's what we need to talk about, all right? What's a nomial? So we're going to start this section off by defining something called a term. There's lots of definitions in this section. Terms, or I'll say a term. Uh-oh. What is a term? So a term is something like this. Let me give you some examples. 5x. 5x squared, or cubed, sorry. Negative 3x squared. 2xy cubed. 4mnz. 8qrs squared. Those are all examples of terms. Okay, I gave you 6 examples there of terms. What you'll notice about a term, there's some things that they all have in common. They all have what? A number somewhere, right? A number. Now it could be that the number is a 1. So let me throw one more term on here. X squared, there we go. I just threw that one in there. X squared is a term, okay? Because it does have a number in front. What's the number in front? A 1, right? We wouldn't write that normally, but there is a number. So all terms have some number, right? And then they have also what? What do we call those letters? What do we call them? Variables. They also have variables. I'm going to put variable /s. That means it may have one variable, it may have multiple variables. So it could have just x there, it could have x's and y's, it could have m's and n's, z's, q's, r's, s's, okay? But terms may contain variables also. Now this is the most important thing. What is the operation between the numbers and the variables? What's the operation? Multiplication. Does everyone see that between those there's really dots, 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 dots? We don't write these dots, but all those dots represent multiplication occurring here. So I'm going to put number variables with multiplication. Right, that's what constitutes a term. With me? Okay, now let's look at something that has maybe more than one term in it. So how about terms, having multiple terms? What about 4x? Is 4x a term? Yes? Has a number and a variable? Okay, if I put plus 5x squared now, is 5x squared a term? Yes. So individually, right, 4x is a term, and 5x squared is a term. So I have a total of 2 terms here, don't I? Together, they are not one term. Together, you can't put them together, and that's what we have to talk about. When can you put these together, when can you not? Okay, but right here, I just want everyone to see we have 2 terms. Now, the next concept here is very important. It's called like terms. Like terms. So what does it mean to be for terms to be like terms? They must have the same variables with exactly the same powers. What do I mean by powers? I mean exponents. A lot of times we call the exponent the power. Not like superpowers or anything like that, right? The exponent. So let's take a look, and you tell me, I'm going to give you 2 terms, and you tell me if they're like terms or not. Okay, as an example. Are these like? Here's the question. Are these like terms or not? 4x, and then comma, here's another term, 7x. Are those like terms? Do they have the exact same variable? X and x, right? What's the exponent or power on each of those variables? It's a 1. So they have the exact same variables to the exact same power, and therefore they are like terms, right? Okay, so the answer here, yes. Okay, let me give you another example. How about negative 2xy and 5xy squared? Are those like terms? Well, do they have the same variables? Yes, right? They do have x's. They both have an x. They both have the same variable y, but they are not raised to the exact same powers. The x's are, right? The x's are both to the first power, but the y's are not. One of the y's is raised to the first power. The other one is raised to the second. Since those don't match, they are not like terms. Got it? Everything's got to be exactly the same. So the answer here would be no. What have I not looked at in both of the problems? What have I not even concerned myself with? The number, right? The number actually does not matter when it comes to determining if it's like terms or not. The number will come into play, but it doesn't tell us anything about whether or not they're like or not. Here's another example. 5 and 10. Are these like terms? Well, are they terms? This is tricky. This is why I'm showing it to you. Are these even terms? Okay, do they have numbers? Yes. Do they have variables? You don't see them, right? Couldn't I write this? I mean, just tell me if this is wrong. X to the 0. X to the 0. What's x to the 0? What's anything to the 0? 1. Isn't there really a 1 sitting next to that? That's an x to the 0. So you could say they both have an x raised to the same power, couldn't you? And I could do the same thing for y. I could put a y in there and put y0, right? That's still 5 and that's still 10, isn't it? So you could argue that there's actually any variable you want to the 0 on both of them, which means that they do have the same variables to the same powers. This is a confusing one. I don't want to overcomplicate it. Look, forget all this. Just look at it. 5 and 10. 5 and 10, anytime you have just numbers by themselves, they are still terms, all right? And they are like terms, right? Numbers are like. When I say like, I'm trying to get you to understand what I mean by like. When you think about like dogs, right? Cats, humans, gorillas, elephants, right? Cats are like animals, right? They're similar to each other, right? Dogs and cats are not like animals. Numbers, 5 and 10, those are like, aren't they? They're the same sort of thing. Up here, the problem above it, that's like a different category. It's not like the 5 and 10. It's not like the cats. It's a different species of things, but they are similar to each other. They are like. Does that kind of make sense? That's the idea here. What's similar, what's not? And then our next question is, how do we add things together? How do we subtract things? All right, so let me just put here to the side, yes, these are like terms, all right? 5 and 10 are like. And so the big question for this section is, how do we add and subtract terms? That's the question. How do we add and subtract terms? What do we need to be able to add two things together? What do you think? They have to be like, right? It's kind of like you get a dog and you leave them together for a while. It's going to work itself out, right? Assuming they're opposite, female and male. Come back, maybe. There'll be some puppies. They're like doggies. They like to get together. You put a dog and a cat together, not going to happen, right? So we need to have things be like before we can add them together or subtract them. So that's the answer to the question. How do we add them? You must have like terms. And then, how do you add them together? Just add or subtract, depending on the operation, the symbol you see, the numbers. Okay, so let's do an example underneath this. Can you find 5x squared plus 11x squared? How many terms do you see? Two terms, right? Are they like terms? Yes, because they both have x. They both have the same power. So can I add these two terms together? Yes. How do I add them? Just add and subtract the numbers, right? Add or subtract the numbers. In this case, I'm adding because it's a plus between them. So I'm taking 5 of these and 11. 5 plus 11 is what? 16. So I should come up with what? 16? X squared, right? You start out with 5 dogs and you add 11 dogs and you should get 16 dogs. So you have to have the same like term at the end. And then subtraction. Let's try subtraction below this one. What's negative 3xy squared minus 21xy squared? So how many terms do you see here? 2. Are they like terms? Yes, they are. So we can add them or subtract them, right? So all I need to focus on are the numbers. Negative 3 and then minus 21. What's negative 3 take away 21? What is it? Negative 24, right? Negative 24. So we get negative 24 what? Xy squared, and we're done. That's the idea of adding and subtracting like terms. Now, of course, we can get a little more complicated. How about something like, another example here. How about 4c squared d cubed plus parentheses 3cd minus 10c squared d cubed? It looks worse than it is. Okay, what does order of operations tell you you have to do? Do what's in parentheses first, right? Now, look in those parentheses. How many terms do you see in the parentheses? 2. Are they like terms? They are not like terms, so can you subtract them? No, you cannot put those together, okay? So don't go trying to do some weird voodoo math and make those somehow go together. It's not, if you do that, you've violated what this section's all about. So we can't do it, so the only thing to do is look outside. Can we drop the parentheses? Yes, but you must distribute through here. What are you going to distribute through to drop the parentheses? What's this? This is a plus, right? What's sitting right outside, right to the right of that plus? A 1, right? So I'm going to distribute a positive 1 through the parentheses like this. I am not multiplying this thing through the parentheses. We're going to do that in a different section, but that's not what's happening here because we have that plus symbol. For some reason, my eraser is not coming up the way it normally does. Okay, so I'm just going to drop the parentheses, right, because multiplying a 1 through doesn't change anything. So I have plus 3cd minus 10c squared d cubed. Okay, now what? Which are the like terms? The 4c squared d cubed, that right there is like the last one, isn't it? Whoa. Now, how many terms did I have total there, though? I had 3 to start with, right? I had 3 there, and only 2 of them are like, so I put those 2 together. So I look at the numbers in front. What's 4 take away 10? Negative 6. So I have negative 6 c squared d cubed. And then what about that plus 3cd? I just leave it there, right? Plus 3cd. Can't do anything to that. Can't combine those together. Those are not like terms. I am done. Questions? Okay. Let's do another one. Okay, how about this? How about 4x cubed minus 3x squared plus 5x minus 7 minus x cubed minus 4x squared plus 3x plus 1, close parentheses. All right, inside the first parentheses, how many terms? In the first parentheses, how many terms are there? 4. Are any of them like terms? No. Second parentheses, how many terms? 4. Any of those like? No. So I can't put anything together. Can I drop the parentheses on the first parentheses? Can I drop it? Yes, because what's sitting in front of it? A 1. Okay, on the second parentheses, can I drop the parentheses? Yeah, I'd have to distribute that negative, which is like a negative 1 sitting in front. I have to distribute that through. A negative 1 distributed through a set of parentheses changes the signs of everything in it. So the next line, what I'm going to do is I'm going to rewrite everything. I'm going to get rid of the parentheses on the first one, which is just going to leave me exactly with what it was. And then on the second one, everything that was positive becomes negative. Everything that was negative becomes positive, because we're distributing a negative 1 through. Now we can start seeing some like terms. I have a 4x cubed and a minus x cubed. That minus x cubed is really like a minus 1, isn't it? So those are like terms. I do 4, I take away 1, that leaves me with what? 3x cubed. Okay, what's my next like term? Negative 3x squared and positive 4x. What's negative 3 plus 4? 1. So I just put plus 1x squared. Can I just put x squared, or do I have to put 1x squared? I can just put x squared, right? Okay, what's my next like term? The 5x and the minus 3x. Put those together, you get plus 2x. And then finally, negative 7, take away 1, negative 8. And you're done. And you can't put any of those together, right? Okay. We're going to do a little more. Two m squared plus 3m minus, in parentheses, 1/3 m squared plus 3/5 m. Your eyes are not tricking you. Those are fractions. Look in the first, well, the only parentheses we have. Can you combine these together? No, they're not like terms, right? One of them is m squared, the other one is just m. So we can't put those together. So distribute the what? Negative 1, right? This negative 1 is going to distribute through like this and multiply to both of those, which basically turns them both, changes both their signs. They started off both positive, they both now become negative. So I will have 2m squared plus 3m minus 1/3 m squared minus 3/5 m. Now, up to this point, we've been able to do this pretty easily because I've been using nice numbers, right? Nice integers for you. This is the first time I've thrown fractions into it. So what we need to do is we need to figure out, first of all, what's our like terms? Well, we have a 2m squared, right? And we have a negative 1/3 m squared. Those two are like terms because they both have the same variable to the same power. In order to put those together, I need to subtract them, so I need to look at the numbers in front and just add or subtract. So I need to be able to figure out what 2 take away 1/3 is, right? And this is all going to go back to how comfortable you are with fractions. I'll do it on the side. I'm doing 2 take away 1/3, right? That's the same as 2 over 1 minus 1/3. Rewriting 2 as 2 over 1. I can get a common denominator, multiply this first one by 3 over 3 to get a denominator of 3 on the bottom. So that becomes 6 over 3 minus 1/3, which is 5/3. So what should these two become then? 5/3 m squared. And now I have to do the same exact thing, but I have to do what and what together here? 3 and then take away, so 3 take away 3/5. So you get a common denominator there. Multiply top and bottom by 5, you get 15 over 5 minus 3 over 5. 15 minus 3 is 12, 12 over 5. So you get positive 12 over 5m. So I'm not showing that one because I showed the other one. Everyone here still needs to be comfortable, or at least be able to go back to adding fractions, subtracting fractions. And then box it up, right? We can't put these together. So we are done. One last example, and then we're going to pretty much move out of this section. We're going to be pretty much done, okay? The last example, I just want you to see some decimals. 0.3x minus 2.2y minus 3 times 0.7x minus 2.9y. So take a look in the first parentheses. Are they like terms on the first parentheses? Are the decimals confusing you at all, or just you still see that the first parentheses only has 2 terms in it, right? The second parentheses, 2 terms, can't put those together. So how am I going to do this? That's why I want to show you. Can we get rid of the decimals? Great question. What do you think? There's something very subtle that I don't want you to miss here. When we multiplied by 100 or 10 or whatever, we were trying to get rid of decimals. We did that before, right? We were doing something called solving linear equations, right? Is this an equation? No, this is not an equation. See, the reason we were able to multiply both sides by 10 or 100 is because we had both sides. We had 2 sides of an equation, right? So what you do to one side, you do to the other. Here, this is not an equation. This is what we call an expression. Expressions you cannot just multiply by 10 or multiply by 100, because it's kind of like me saying, hey, look, here's the number 2. Can you just come into 2 and multiply by 10 and it be the same thing? If I multiply 2 by 10, I get 20, right? Is 2 the same as 20? No. But if I say x is equal to 4, if I say multiply both sides by 10, it becomes 10x equals 40, doesn't it? Is that the same thing, though? Yes, because, look, if x is 4, plug that in right there. What's 10 times 4? It's 40. So it maintains the balance of the equation when you do it to both sides. So this is exactly why I showed you this example, because I was hoping someone would ask whether or not we can do that. So thank you for filling in perfectly there for me. We cannot get rid of the decimals that way. Therefore, we must work with the decimals. So can I drop the parentheses on the first one? Yes. All right. In order for me to drop the parentheses on the second one, what will I need to do? Distribute a -3 through, right? So you might need your calculator. Maybe not for this, but on your homework you might. What's -3 times 0.7? -2.1x, right? Now what's -3 times -2.9? Positive 8.7? Y, right? Now do we have like terms? We've got a 0.3x, right? And we've got a -2.1x. Those both have the same variable to the same power, so I need to be able to add the numbers in front or put them together. What's 0.3 take away 2.1? -1.8 x. And then the other like terms I have are the -2.2y and the 8.7y. So go ahead and put those together. -2.2, add to that 8.7, you get 6.5y plus 6.5y. And you can't put those together because they're not like terms. So we are done. Questions? How does this seem to you? Seem okay? Get some practice with this at home on your homework assignment, which will come off of page 380. And what I'd like for you to do is 25 through 33 odd. I'd like for you to do 59 63 and 65. Okay. Now, we're going to jump into the next section. It's 5.6. Multiplying. Multiplying what do you think? These polynomials? Now, what I did not do in the last section is I really did not define what a polynomial was. I kind of did that on purpose because you really don't need the definition until now to really understand. I guess to be able to do multiplication, we need to really understand, I guess, what a polynomial is. So let me define it for you. A polynomial is just a collection of terms. Terms. Poly meaning many, nomial meaning terms. So having many terms. We've already looked at polynomials. The problems that we were doing right here. Okay? This boxed answer in red here, that is a polynomial. It's many terms, isn't it? A collection of terms. So we've been dealing with polynomials already. Now, we do have some special names for special polynomials. Here's the first one. A monomial. What do you think that means? What does mono mean? One. This is any time you have one term. We call it a monomial. So we've seen monomials already, haven't we? It's the monomial. There it is. One single term. Okay, what do you think we call two terms? Binomial. Two terms. Bi meaning two. What do you think we call three terms? Trinomial. What do you think we call four? Quadnomial, right? I mean, so there are different things you can call it, but we usually stop at three with the names, okay? After that, we just start saying how many terms there are, okay? So this would be a polynomial with 4 terms, or a polynomial with 5 terms, polynomial with 6 terms. Because you start running out of words, or the words start getting like complicated, and you've never heard them before, right? What would be 8 terms, like an octnomial or something? I mean, it starts getting kind of ridiculous at some point, right? So, but we see monomial, binomial, and trinomial so many times in real math applications that we just have nice nicknames for them, okay? So what we need to do now is we need to look at how we multiply things like this. I mean, go back to the example right here, this right here. When we did this problem, we had, right here, how many terms are there? 2, right? How many terms are here? Inside the parentheses. 2, right? So essentially what we had was 2 terms and 2 terms, and we were subtracting them, right? 2 terms. So this was like a binomial, and we were taking away a binomial, weren't we? In the previous problem, right here, look at that one. We had 1, 2, 3, 4 terms, and we were subtracting another 4 terms, weren't we? 4 take away 4. How about this right here? What was that? That was a monomial, single term, plus a monomial, right? So you can take like a monomial and add to it another monomial, and you can take a monomial and add a trinomial, a binomial. What we need to do is figure out now, how do we multiply this? Adding is pretty straightforward. Drop parentheses, collect like terms, look at the numbers in front, we're pretty much done. But with multiplication, it gets a little more complicated. So here's our goal. I don't know how far we'll get with this, but here's our goal. Our goal is to be comfortable with the following types of multiplication. What happens if I take a mono, I'm going to say mono instead of monomial, and I multiply it times a monomial? How do you do that, right? We need to be able to do a monomial times a monomial. Then we need to say, well, how about if we have a monomial and we want to multiply it times a binomial? And then we need to say what happens, or how do we do a monomial times a trinomial? Understand? After we figure out how to do monomial, monomial, binomial, monomial, trinomial, then we'll try and figure out how to do binomial, what do you think? Trinomial. Do you think we'll do binomial, monomial? Well, we already did that, didn't we? Right here, that one, right? So we don't need to do it again. After we do this, what do you think we're going to need to be able to do? Try, right? We haven't done that one yet. We have to be careful. We have to be comfortable doing all of those, all 6 of those things. So I'll see if I can do monomial. See how long it takes us to get comfortable with that, and then we'll probably call it a day. So let's start. Somebody give me a monomial. 3x, is that what I heard? Okay, I'm going to put it in parentheses just because I want everyone to see that's a monomial. Somebody give me another monomial. 7 what? 7x. Okay. All right, I'd like to multiply those. So do you see that there's multiplication between those? Because I didn't put a plus or a minus, right? Now, just for the sake of looking at this and making sure that we see it, are these like terms? Yes. So we could add them, couldn't we? We're not being asked to, but we could. How do we multiply these things? Well, since there's multiplication everywhere, this is really 3 times x times 7 times x, isn't it? And that's just 3 times 7 times x times x. I just rearrange things because it's multiplication. I can slide things around. What's 3 times 7? 21. What's x times x? X squared. Right? You got x squared by doing what? Adding the ones together, right? There was like a 1 on each one of those. You added the exponents, it became an x squared. So when you take 3x and you multiply it times 7x, you get 21x squared. See, multiplication is weird. It's like you put a dog and a cat together, you get an elephant. It's not the same thing. You see that? We're getting a 3x and a 7x, getting something completely different when it comes out. Now, did they have to be like terms for me to do this? I asked for 2 monomials. Someone gave me 2 monomials. They happen to be like terms. But let me try something else. How about 3x squared, and how about 4xy squared? Are those 2 things in parentheses like terms? No, but am I trying to add them? No, I'm trying to multiply them. So it does not matter that whether they're like or not. All that happens here is I drop all the parentheses, I put everything together, and I multiply. So I'm trying to do it all in one step here. The 3 times the 4, I'll put that together. I'll put the x squared times the x, and then I'll tack that y squared onto the end. What's 3 times 4? 12. X squared times x. X cubed. You got that by adding the powers, right? These are properties of exponents we've seen already. And then y squared. And we're done. Yep. Monomial is pretty clean. It's really just multiplication. That's all it is. Straight up multiplication. Now, you can imagine that, you know, someone could throw a fraction out here. Yeah, let me do that to you. Just so you see it, right? What if I have negative 3/4 m to the 7th q times 1/2 mb cubed? All right, very important for us to see that the operation between this is multiplication, right? Inside the first parentheses, I can't put anything together, right? There's nothing to do in the first parentheses, nothing to do in the second parentheses. I'm going to multiply the two monomials together. So let me put my numbers first. I need to do negative 3/4. I need to do times 1/2, not added, right? M to the 7th. I have an M in the other one also. Then I have a Q and then a B cubed. What is negative 3/4 times 1/2? Negative 3/8. How did you get that? How do you multiply fractions? Straight across. Negative 3 times 1 is negative 3. 4 times 2 is 8. Okay, m to the 7th times m. M to the 8th, q, b cubed. I don't change any of those, right? And that is it. We are done. Since y'all seem to be pretty okay with that, promise this will be the last thing we do. Let's try our monomial times a binomial. So let me give you an example underneath. 5x squared. Is that a monomial? Yes? In parentheses, I'd like to multiply that times a binomial. Now, a binomial is going to have how many terms? 2. So I just need to write something with 2 terms in here. So I'll make it up. Negative 3x plus 4xy. Are those 2 terms in that parentheses? So that is a binomial? Are they like terms in the parentheses? No, so I can't put them together, right? So does everyone see the monomial times the binomial? Yes? So how should we multiply that? What do you think we're going to do? Distribute, exactly. We're going to do this times this. So the monomial is going to pass through the parentheses, just like a number has done in the past. So watch how I write this. I'm taking my 5x squared, and the first thing it's going to do is multiply times what? Negative 3x. And then I'm going to say plus the 5x squared times the 4xy. Do y'all see that? 2 different multiplications. The first one goes from here to here, and that gives me this. The second one goes the monomial to the second term, and that gives me this. Now, each one of those is a what times what? Each one of those is a monomial, isn't it? So you're going to have to do monomial, and then monomial again. Okay? So let's do it. What's the first monomial? Negative 15 x cubed. And then the other one? So plus 20 x cubed y. Do y'all follow the idea here? Box it up. You can't put those together, right? They're not like terms? Okay, I'm gonna give you just a few problems for homework here. We'll have to pick up with the rest of this next class. Page 389. Let me see. Let's go 15 through 20. All. I'm finishing 5 minutes early. If anyone wants to talk about their grades again, after today you cannot drop the class, so I have to give you a grade at the end. So if you have any concerns on your grade, please talk with me. Have a good day. Where's my mouse?